Hello and hi. Assalamualaikum warahmatullahi wabarakatuh. My name is Ieskandar Zulqarnain bin GHAZALI and my teammate is ZHOU CHENXING. So firstly, I will explain about the lab 1 of computer architecture. So the first thing is I will explain about the part A for the lab 1. So this one is the code I already copy into the Visual Studio. So the first thing first is which is the line 9 is do a move statement. So 10,000 will move the EAX after it executes the line. So next the 40 the line 10 is do the addition one, which is the 4,000 which will added to the register EAX, and next line do the subtraction for the register, which is subtract with 2,000 and it became 3,000 hexadecimal. So the line 12 actually it just display all the register that we execute. So I will run this code and I give ZHOU to explain it.
Okay, as we can see here, the output is EXA equal 3000, and the next EBX to the EBP is the address of the registration, and so on. Hey, also this one's the address of the registration.
Okay, for the next one, we will explain about the part B. So first I will tell you about the code. I'll already copy into the Visual Studio and I give to the ZHOU CHENXING to explain about it. The floor is yours.
Okay, here the line 15, as we can see here, move EXA value 1 start with 1000, and the next line, which is 8 EAX value 2 and add with 4000, and then subtraction EXA value 3 subtract 2000 and move final value EXA store the result 3000, and call a dump breaks display the register. So we shall run the code.
So basically this output will come out and EAX is became 3000 because we do all the operation, which is we move the val1 into the register. So val1 is will declare with 10,000 and we add and we subtract, and the last output for the register EAX is became 3000, and others is only the address for the register, which is the address for EBX 0021 7000. Okay, so if we want to know how the output is do and it's execute, we can do the step over step. So for the step over, I already put this wash, which is val1, val2, val3 and final val. So val1 we declare with the double word, which is 10,000, and val2 we declare with 40,000 hexadecimal, and val3 2,000 hexadecimal, and final val is 0 because we need to move the EAX after the code is execute and move the EAX into the final val. So the first thing first, I will do the step over. So I give this floor to the ZHOU CHENXING.
Uh, so it's not clear. Cannot.
Wait. Okay. Okay, ZHOU, can you explain about the autos and watch?
Okay, here as we can see for the EAX, the address is 0019 FFCC. So here we move the value 1 to EAX. So it will become from 1000 to 10,000 here. As you can hear here, the value 1, the value now changed to 10,000. And then we add the value 2, which is 4,000, and to the address. Now here, as we can see, it becomes 40,000. And then for the value 3, we subtract value 3, and then to the address from 2,000 come to 20,000 there. And for the final result, and then call the dump flags display the registers. See here the final value, which is 30,000. Here's the output, 3,000.
Okay, for the next one, we will execute for the part C for the lab 1. So I already copy also I already copy the code into the Visual Studio. So first thing first, I will explain about it to you about this. So val1 is the variable, so word is the data type for the value 1. So this is the value for the variable. So and so on. So value 2 we assign it with 4,000. Val w3 we assign with 2,000, and finally val w we did not know because we will execute the code and assign the register into the final value w. So also this one about the val1 b1, so the variable is val1 b1, and the byte is the data type for the val1 b1. So all of this is the code, is the code to execute the assembly language, which is we move the val1 w1 into AX because we use the word, it's only consists for the 8-bit and 1 byte. So after that we go to the line 26, which is we move the value 1 b1 into the AH we use, because we use the byte only consists of 4 bits actually. So we need to cut the register, which is from the EAX into AX, and we divide by 2, which is AH and AL, which is AH is register for the upper, and AL is the register for the lower. So the code we execute, we do the subtraction, additions, and we assign the AX into the final value. So also same with this one. So I wish all to run this code, and I give the floor to the ZHOU CHENXING. Okay.
Okay, after we execute the code. So for the first one, as we can first step, as we can see here, is the output EAX equal 19300. So for the EBX and so on is the address of the register. And also here, as we can see here, the output which we move value 1B1 to AH and so on, or add and subtract and move, and we can get the final output, which is EAX equal 00193999. And also after this, and from EBX and so on, this is the address of the registers.
So if you want to see more clear about this, how the value go, how the value execute, so we need to do the step over step. So if we can see, I already assigned to I already do the watch, which is val 1 w1 val w2 val w3, and the final value for the w, and also this val 1 b1 val b2 val b3, and the final value for b. So we do the step over. So we can see the AX is become the address for the AX is 0xFSCC. So I give the floor to the ZHOU CHENXING.
Okay, here we move a value. Oh, sorry.
Sorry. Okay, can you start?
Okay, here we move this value A1 W1 to AX, and to the AX this address, and we can get actually first its value is 1000. It's 10,000. After we move to the address, we'll get 1000. And for the value 2, we add to the X the address, and it will from 4,000 40,000 to 4,000. And then for the value W3, and we subtract this value to the AX, and it will become from 20,000 to 2,000.
Actually 2,000, 5,000 to the 3,000. So the next one, ZHOU CHENXING, the AH.
Okay, AH. For the AH, the address, which is 0x300. Here we move value 1 B1 to AH. The address, it will from 10,000. The value will change to 0x10 x10.
Yes.
And then for the value 2, we add to the AH the address, and the value will become to 0x40. And then for the value 1B3, we subtract this value, so it will from 20,000 change to 0x20.
00193000.
This is the output.
So the output for the EEX is became 00193000 because we do the AH, the upper uh, the the upper for the byte. Okay, uh, that's all from us. Thank you.
Okay, thank you. Thank you for watching.